Hello, physics students. We're going to do problem 11. So let's jump right in, get this thing cranked out. So here we are, and we have this rectangle, and we're given some distances, so I can put those distances in here. This one is 9.3 centimeters. I'm going to convert it to meters.
It looks great. All right, now it's time for me.
There's meters.
No, it's not. I'm going to come in and inspect it.
Okay, here we go. And we have 4.3 centimeters, so it's 0.043 meters. Okay. And now we're given that these are all equal in charge. So I'm going to call them Q1. So Q1, but this is also Q1, right? Because they're all equal in size. So we can all call them all positive too if we want. So it could be all negative, that doesn't matter. I know that doesn't tell us in the problem, but we can just assume. We have some current wrestling going on, a sword here in the Hendershot household. All right. Anyway, there we go. We have all positives here. And then we're given this here. Now it wants the force on A exert on B here. But we can't solve that yet. We're given a force of C on B. So let's set up Coulomb's law. F equals KQ1 times Q, we'll call it QB times QC all over R squared. Now, good news is we know, well let's just fill in what we know. 8.99 times 10 to the 9th. That's our K. Okay, then QB and C are both Q1 because they're equal. So Q1 times Q1 all over 0.043 squared. Now, Q1 times Q1, isn't that Q squared? So this is 8.99 times Q1 squared all over 0.043 squared. And you could turn that into a number if you wish and have it down there already. Oh, this is times 10 to the, times 10 to the 9th times that. And, but force, we do know the force of this. It's 32.2 millinewtons. 32.2 millinewtons is 3 to turn it into the, this way, 3 to turn it into regular newtons, 0.032 newtons. So it's, if you want to set up the conversion, 32.2 millinewtons. Sorry, it's getting a little messy. And it's 1,000 millinewtons in 1 newton, the prefix milli. So we divide by 1,000 and we get this here. So we can fill this in. Okay, so now we're going to solve. So I'd multiply by this 0.043 squared, divide by this K value, and then take this square root. Well, I'll just do it this way. Q squared, after you get this all down to here, gives us 6.6226 times 10 to the negative 15th. Take the square root of it. Need some more room. And you get Q is equal to 8.1379 times 10 to the negative 8 coulombs. There we go. So now that we know Q, like, well, how did that help us? Well, now we can go back up here and do Coulomb's law with A and B. Okay, so we're going to do Coulomb's law with A and B because all the charges are the same. So I just might as well switch to it. So it is times Q1 times Q1 all over R squared. We can fill in 8.99 times 10 to the 9th. And we know our charge, this is it, right? Which is 8.1379 times 10 to the negative 8th. And then I would write it again, right? But since it's the self, can't we just square it? Since it's, we'll write it out. I don't want to confuse someone. We're still just filling into the formula, but you could have just squared this, which I actually is just this number right here if you wish to just use that instead of both of these here. So there we go, all over. And our distance is the 0.093 up here. There we go.
Hey, Mommy, can you open this? Open this, Mommy. Open this.
Meters. We'll leave the meters off, as in my typical fashion. I've checked to make sure the units are okay and play nice. If we want to force in newtons, this has to be in meters, these have to be in coulombs, and you have to use this constant. And they are. So sorry about that. Maybe I should have ran through that and told you we were making the units play nice ahead of time. Well, when we fill in here, the force from, we'll call this force AB, is actually equal to and it will take this, then the answer converts it to millinewtons, so that's our answer, and if you saw up above, it is 6.88 millinewtons, so you can, if you wish, but I inputted the answer like this, either one is acceptable, and you're good. That's part one. Now part two, what is the total force acting on B here? We have two forces. We have, since they're all same charges, it's pushing it to the right. Q1 is pushing to the right. And that's QAB. What's QAB? This simple right here. This newtons. 0.00688. Okay. 0.00688 newtons. What's this doing to this? This was told to us in the problem. It's pushing it up at 0.0322 newtons this way. So those two, what does that give us? Let's go down here and do a free body diagram now. So here is the dot, this is B, and what's being done to it here and here, and we can move these. Remember when we're adding these, that we can put them head to tail, vectors. And you have them when they're perpendicular to each other, you can just put them head to tail. Actually, they don't have to be perpendicular, but that's a whole nother story and a whole nother unit. So we can just put them like this. And the answer is going to be the hypotenuse here. So that is going to be the actual ultimate force onto us. So it's just a Pythagorean theorem deal. 0.00688, and this one is 0.0322. And when you do a squared plus b squared equals c squared, and fill in and solve, you end up with a c value of 0.03293 newtons. Very close to this, right? But this is a very tiny leg, so not to scale, but there we go. And let me know if you have problems.